Hey Math 20-1. So I just want to make a quick video on solving system of equations by graphing. What I mean by systems of equations, it means more than one equation, so that's where the system comes from. And solving means that we're asking what value of x could we put in to these equations that would give us the same y value for both. So this will look a little bit easier if I just write these formulas in a different way. I'm going to rewrite these formulas with y is equal to. So what I'm going to do is take this y, and I'm going to just move it to the other side. So if we do that, we'd end up with an equation that's more familiar. Y is equal to 4x plus 3. And let's rewrite this one with y on the other side too. So that would just be y is equal to 2x squared plus 8x plus 3. All right, so you can see we've got two equations here. We're asking what values of x could we put in here to get the same y output. If you kind of visualize what's going to happen here, this might make sense with the graph. So this graph is going to be a linear graph, right? So it's going to look something maybe like that. This one, the second one, is a quadratic, and it's opening up because the front is positive, so I know it's going to look something like, I don't know, something like that, right? So we're going to have two spots here where both graphs intersect. That's what we're interested in. And you can see that where one graph intersects the other, so right here, we're saying what's the x value right there where the y value is the same for both, right? So there's going to be a spot right there, but there's also going to be a spot right here. So there's going to be, in this situation, there should be two places where this does happen. In this situation, there probably is two places, but there might also be, there's a couple situations that can happen. So this is one of those situations where it crosses, right? It makes two different points where they intersect. But it could also be the case that, I don't know, we had something like this where the line just touches and then goes off. So that would be one, there'd only be one solution there. But the other situation would be where you have something like this where the lines never do touch, and then there would be no solutions. So that's the only kind of three possibilities there are for this setup. Okay, so what we're going to do, we want to figure out where they intersect. So what I'm going to do is actually just plug these things into my calculator, both of them. So y is equal to and y is equal to. So if you do that, I put my first one into my calculator here. So f1 of x is equal to 4 times x plus 3. Then we're going to go, all right, f2. I'm going to put in 2x squared plus 8x plus 3. Okay, and then I'm going to push enter, and you can see I've got kind of what I sketched there before. I was off a little bit. I was a little bit wrong. What I'm going to do is I'm going to grab these things in your calculator. If you press down the center button and hold, the little guy's grip will be able to grab onto that. Oh, he'll make it easier because you can just move it around and out of the way. What we're interested in is where they intersect. So all we got to do now that we have these two graphs is you go to Menu, Analyze Graph. You've got a few tools in here. You can figure out your x-intercepts, your zeros, I mean. Minimum, maximum. But we're interested in the intersection right now. So if you go intersection, and then just always go to the left of it first. It says lower bound. Upper bound is always going to be to the right. And I can see it's kind of overlapped a bit, but I can move it again. They intersect at point 2 or -2 when y is -5. So they both have that in common, right? So one of our solutions for x is just 2 right there. The other one, we go Menu, Analyze Graph, Intersection again, and then I just do it again up here. So I just go to the left of where they intersect, to the right, and it says they intersect at 0, 3. So my two solutions for this would be x is equal to 0 and x is equal to -2. One thing that you should do though is check to make sure that that's actually right. So if we do that, all we got to do is throw this 0 into our equation. So for the first one, I'd say, okay, let's throw 0 into both these and see if we get the same y out. So for the first one, we have y is equal to 4 times 0 plus 3. So y is equal to 3. Let's see if that's the same for the second one. So if we throw 0 in the second one, y is equal to 2 times 0 squared plus 8 times 0 plus 3. Yeah, y is equal to 3 for the second one too. So 0 definitely was a solution. It worked for both. Negative 2, let's try that one. All right, in a different color here so we don't get it. Oh, whoa, that was weird. Right over here. Okay. So if we put negative 2 in this time, so let's go for the first equation up here. So that would be y is equal to 4 times negative 2 plus 3. That would be equal to negative 8 plus 3, so negative 5. So the first one's negative 5. Let's see if that's the same for this one. Y is equal to 2 times negative 2 squared plus 8 times negative 2 plus 3. So we have y is equal to the negative part here, right? That becomes positive, so this is just 2 times 4. So 2 times 4 is 8. So this part's 8. Plus 8 times 2 is negative 16. So I just have minus 16 plus 3. In this case, y again is also negative 5. So yeah, both of those solutions did work, and we checked. Okay, so that's all I'm going to say about that. I'd like you guys to go ahead and do the assignment that I put on the website. So I'll see you guys in class.